Art Boys, I just wanted to give a little update. I just discovered something crazy right now. So let me show you how I first discovered it. Um, I opened up this ESC I bought online. I bought some ESCs just to study like how they do it, so I can maybe get some tips on how to do mine when I do my dead bug style or whatever for flexible circuitry reasons. And I opened it up and I saw that these these six Mosfets right here are actually significantly smaller than what I've been buying, which is the IRF 3205. They're way smaller. So the IRF 3205 is an N-channel MOSFET that has 110 amps continuous rating, and it has max 55 volts. And I thought that was fantastic. I snap off the little tab on the top, and it's still pretty small. And I thought we're good to go, right? And I can bend these arms down and then bend them back out again to make it like a flat profile on the bottom. So it's kind of like SMD style. But then when I looked at the MOSFETs in this one, this is an ESC that's a 30 amp ESC, 12.8 volts max. They say that, but it might actually be spec to do a lot more. And check it out. Look at how much smaller it is. So this one compared to this one, it's night and day. Even like from this angle, you can see like these are much flatter too. Let me look at it like this. Some pictures. Um, like the MOSFETs I'm working with now, this is what I'm working with is thicker than the whole board and MOSFET combined. Look how flat these are. If these MOSFETs right here, I was like, well, if they're that much smaller than this, they must suck, right? Well, I looked up the part number and I couldn't find a data sheet for the part number, but then I was shopping around because I saw that based on what I could find, it said that this is a type TO-252. And this is a part form factor of TO-222 or 220. So this is a 220, and this is a 252. 2 is TO, and then there's a hyphen. So this is 2 TO hyphen 220, and this is TO hyphen 252. The TO hyphen 252 is a SMD style. This is more of a DIB style. SMD style. Okay, so I figure these probably can't give you much amps. They're probably trash specs, right? These can handle up to 30 volts. This handles up to 55 volts, so there's an advantage here. But up to 30 volts is fine for pretty much all the motors I bought, most of them. So that's fine. And then the amps, I thought would be really low, right? These can handle, well, okay, I don't know the amps specifically on this. The ESC says it can handle up to 30 amps, but that's based on the whole circuit board's design, how hot it gets, based on its heat sinking abilities, etc. It's not based on the actual potential of these individual MOSFETs. It's based on the potential of the whole board, being that the board has limited heat sinking, it's not water cooled, etc. So that's what limits the amps on the board's ratings for the board, which actually comes shrink wrapped. All this was shrink wrapped. I had to cut that off. So it has really no airflow cooling it off at all, no fan, nothing. So that's why they get such low ratings on it. But the actual Mosfets themselves, like if this board is properly cooled, they would be able to produce way more amps. But they're just going based on, how thick their traces are and how well cooled it will be in a typical use case. So that's why it seems like it can only handle much lower amps. So anyways, all that to say, I found out the TO-252 form factor of this. I found another one online that's comparable, probably about the same specs, and it's this. So it's called IRL R7843 PBF. That's the model number. It's 100 pieces for like $7. I don't know why they're doing euros, my currency. Okay. Okay, so it's $7.40 and $3 shipping for 100 of them. So I bought 300 of them for $27 shipped. And that will make 50 ESCs for only $27. That's insane. It comes out to 10 cents each then. That's insanely cheap. 10 cents each. So a single ESC only costs 60 cents worth of the main Mosfets that make the whole thing. So basically it's like $1 for the, well, 60 cents, but let's just figure $1. And then like $1 for all the other parts. So basically to make my own ESC then costs only $2 in parts. Maybe only $1.60 or $1.70 for really not run up. That's insane. That's so cheap as far as materials. Now, you're like, this must be too good to be true, blah, blah, blah. I bet this can't handle much amps, right? Check out the amps. This says it can only handle a maximum of 30 volts, which will handle most brushless DC motors that I bought. And it can handle pulse drain current of 620 amps. Are you kidding me? And 161 amps if it's kept at a decent temperature of continuous drain current. That's even higher than my beefy N-channel MOSFET. The TO-220 style that I've been working with, the IRF 3205, which I thought was so good. Its continuous drain current is even higher than that, I think. I'd have to look up the data sheet, but that's what I've written out. It can handle 110 amps continuous. So suffice to say, this thing is an absolute beast, and it's way smaller. And so I'll be able to miniaturize my ESCs a lot more, which I need in order to fit them. I need all the miniaturization I can get from my robot. So this is huge. This is a big discovery for me. And I'm no longer going to be using the TO-220 for anything that is lower voltage than 30 volts. If I need something like 55 volts or whatever, then I could bump up to these bigger ones. But as long as we're well under that voltage-wise, I can use these SMD style power MOSFETs that are absolute beasts as far as current capability. And we'll be able to fit these ESCs snugly tight against the motor and hardly take up any space at all with them. It's just they're so flat. They're incredibly flat. So they will hug against that motor tight. And we'll be able to not have to worry about the electronics being like too space consuming this way. They're going to take up so much less space than I ever could have imagined. So this is a big discovery because I've really been concerned about how am I going to fit everything, and now it's like, okay, we got this because we can fit the electronics easily now. So this was big.